if we find the factors of 125, they turn into 25 and 5. All right, we keep on going. The factors of 25 are just going to be 5 and 5, all right? So, ooh, something's happening, something's happening. And then the factors of 5 are just 5 and 1, all right? I'm going to keep these 5s as just 5s because we already know what the factors of 5 is from this one. All right, so if we put this all together, we can make it as 5 times 5 times 5 times 1, all under that square root. Don't forget that negative. It's going to come in handy. All right, so if we combine these 5s, it's going to turn into 5 squared times 5. That 1 goes away because anything times 1 is just itself, right? So what do you guys know about square roots? If we have something squared under the square root, and if it's square root like that, remember in the prior example where we could take a fractional exponent, this turns into negative 5, 2 over 2 times 5 to the 1/2. That 2 over 2 is what? Oh, why did that? Okay. That 2 over 2 is just 1. So that turns into negative 5 to the first power. And anything to the first power is itself. So we have negative 5 times 5 to the 1/2. All right? And then 5 to the 1/2 is just square root of 5. So in total, we have negative 5 over the square root of 5 for that one, right? So this guy over here, 3 times the square root of 45, we're going to do the same exact thing. The factors of 45 are 9 and 5. And then let's say, what are the factors of 9? That's just going to be 3 times 3. And factors of 5, you already know it from over here, so we don't have to write it again. So if we write all of that under the square root, we have 3 times the square root of 3 times 3 times 5. All right, following the same exact steps as these guys over here, we're going to have 3 times the square root of 3 squared times 5. Exciting things are happening. So 3 squared under the square root is just going to be 3 times 3 times 2 over 2 times 5 to the 1/2, right? So what is that 3 to the 2 over 2? That's just 3 to the first power. So we have 3 times 3. So that's 9 times 5 to the 1/2. Right, and 5 to the 1/2 again is just the square root of 5. So in total, we have 9 times square root of 5. Right? So that's this part. Now we have the two parts. So we have negative 5 square root of 5 plus 9 times the square root of 5. And since they have the same bases of the same square root of 5, we can now combine them. And it's just going to be negative 5 plus 9, which is just 4 times the square root of 5. All right, so that is the final answer for this one. Okay, it looks confusing, right? But we know about rational exponents. We were dealing with them from prior two examples, all right? So we shouldn't be scared for this one. Just incorporate everything that we've learned so far into this one and we should be fine, right? So then, what do we know about factoring when it's something like this, when we have terms over here and terms over here, right? We look at these terms separately and then we find out what they have in common. with each other. My first reaction is to look at the constants in the front of both factors. So we have 4 and 7. What's the same between them? Not really anything, so we're going to keep that in mind and keep that there, both those constants. So let's move on to the other factors. We have a 6x plus 7 to the 1/3 power over here, and we have a 6x plus 7 to the 4/3 power over here, all right? So what is the highest exponent that we have for both of these? That's going to be 6x plus 7 to the 1/3 power, all right? So our next step is going to be taking that 6x plus 7 to the 1/3 power out of, whoa, that is a horrible 6, out of both of these terms. So we're going to do that first. We have 6x plus 7 to the 1/3, all right? Now let's move on to the next factor. We have a 4x plus 1 to the 11 over 7 on this side, and we have a 4x plus 1 to the 4 over 7 on the other side, all right? What is the highest, going back, it was the lowest exponent that they have the same, all right? So for this one, retracting back, what is the lowest exponent that we have for a 4x plus 1? Is it 11 over 7 or 4 over 7? It's going to be 4 over 7. All right. So we're going to take a 4x plus 1 to the 4 over 7 out. All right. So now we could put a little bracket over here to work with these terms individually. So now what are we left on this? Well, so what's left on this left side? We have that 4 still, so we could write that. But do we have a 6x plus 7 still? No, we don't, because we took out a 1/3 power already from it. All right, so let's move on to the next term. We have a 4x plus 1 to the 11 over 7. What are we left with on this side? If we took a 4 out of 7 out of an 11 over 7, we're just going to be left with a 4x plus 7 to the 7 over 7 power, all right? Because if we took out a 4 over 7 from that exponent, remember, when we're working with exponents, we're going to subtract the exponent. So it's going to be 11 over 7 minus 4 over 7, which turns into 7 over 7, right? So now we're done with this left term over here. So now we can move on to the next one. So what are we left with? That 7 is still there, right? So we're going to write it down. We have a 6x plus 7 to the 4/3 power, all right? So we took a 6x plus 7 to the 1/3 power out of both. So that means 4/3 minus 1/3, that's going to be a 3 over 3 that is left over. So it's going to be 6x plus 7 to the 3 over 3 that is left. All right, so let's move on to the next one. We have a 4x plus 1 to the 4 over 7. We already took out a 4x plus 7 to the 4 over 7 from both of these. So that means all we're left with is just this. All right, so something nice happens in the fact that 4x plus 7 to the 7 over 7, if we simplify this, and also 6x plus 7 to the 3 over 3, if we simplify these, that just turns into a first power. And what do we know about first powers is that anything to the first power is itself. So what we are really left with under the bracket, or in the bracket, we have a 4 times 4x plus 7 plus 7 times 6x plus 7, all in the bracket, all right? And we're also left with these factors out here, all right? Don't forget these factors, okay, guys? If you do, you're going to get the question all wrong. All right, so now what's the next step? We're going to deal with what's in the bracket. We're going to combine like terms. But before we do that, we have to distribute into the parentheses. So if we do that, it's going to be 4 times 4x, so that's a 16x. 4 times 7, that's a plus 28. And now on this side, we have a plus 7 times 6x, so that's a 42x, and a 7 times 7, so that's a 49. All right. Combine like terms, we have a 16x plus 42x, that's 58x, and a 28 plus 49, and that's plus 77. Hopefully I did my math right there. And then all we're left with is bringing those factors down, and our final answer should be 6x plus 7 to the 1/3 times 4x plus 7 to the 4/7 times 58x plus 77 as our final answer. Wow, that's going to be tough to circle. Okay, we got it. FA for final answer. Right, kind of deceiving. So we have an 8x minus 4x plus 3 is equal to 6x minus 21. All right. So it wants us to solve the equation for x. So we look at this and just like combine like terms, right? Let's say we don't pay attention to this minus sign. We're going to just do 8x minus 4x, which is 4x, and then we do plus 3, right? And we think, oh, it's going to be a 4x plus 3. And that's going to get you the wrong answer. All right, guys? This, although it might seem easy to some of you, this like concept of distributing out your negative signs is going to follow you for the rest of your like mathematical career if you guys want to pursue more. But you guys are going to see this a lot where you might make an error with distributing that minus sign right there, and then it's going to give you the totally wrong answer, and you're just going to be like, why did I get this wrong? I thought I did everything right. Well, you didn't distribute the negative sign. So if we want to do good and get all our answers right, let's figure this one out and see what's happening. So we have 8x minus 4x plus 3 is equal to 6x minus 21. So we have an 8x, and we want to distribute this negative inside, right? It's going to be 8x minus 4x, so that stays the same. But this minus and that 3, it's going to turn into negative 3, which is going to equal 6x minus 21. All right, now we can combine like terms. All right, guys, so it's a 4x minus 3 is equal to 6x minus 21, right? Subtract negative 6x on both sides. It's going to be equal to negative 2x minus 3 is equal to negative 21. Add 3 on both sides, so we have a negative 2x is equal to negative 18, and then divide negative 2 on both sides, and we're going to get x is equal to 9. All right, guys, although it might seem easy, again, for some of you, it's a very, very important, like, not concept per se, but just something to look out for in your problems, all right? You guys are going to be dealing with a lot of negatives, and I just don't want you guys to get any question wrong just because of that. All right, guys, so, well, if you see something like this, your first step should be to cross multiply. All right, so if we cross multiply that x with that 4 and that x with 6 with that 5, that looks kind of clunky, but I'm pretty sure you guys get it. We have 4x, which is going to be equal to 5 times x plus 6. Okay, we want to solve for x, guys, so we want to distribute that 5 into the x plus 6. So that's going to be 4x is equal to 5x plus 5 times 6, which is plus 30, right? So now we subtract a negative 5x on both sides, or we can subtract a negative 4x on this side and a negative 30 on the other side. Whatever your preference is, just be sure to be cognizant of your time. You know, all your tests are timed and you want to get through the test as quickly as you can and as efficiently as you can. So, gotta subtract negative 5x on both sides. We're going to get a negative x is equal to 30, right? We still have that negative out there, so we have to divide by negative 1 on both sides. So that's going to be x is equal to a negative 30 for this one. 30x minus 11 is equal to 30 over x. So, remember the prior problem where we had those two fractions, right, and those two variables, right? It's basically the same exact thing. Although this 30x minus 11 doesn't show another fraction, we could think of it as being 30x minus 11 over 1, which is equal to 30 over x, right? Always having that trick of knowing that anything like this that doesn't have a fraction or anything is over 1 is kind of a neat trick that might help you in more problems in the class to come, because you're going to run into some things that you might need a factor, things like that, grouping by factoring, all right? And this technique is going to work out perfectly for you guys, right? So if we know that 30x minus 11 is of 1, that means we can do the same thing as we did in the prior problem and multiply both sides by cross multiplying. All right, so it's going to be an x times 30x minus 11, right? Let me just draw the arrow so you guys know for sure, which is equal to 1 times 30, right? And that's just going to be 30 eventually, so I'll just cross that out. All right, so that's going to be x times 30x minus 11 is equal to 30. Let's distribute that x inside, right? And x times 30x is going to be 30x squared, all right? X squared now. So we're dealing with some factoring problem. All right, so x times a minus 11 is going to be a minus 11x, and that's all equal to 30, okay? So, let's see. We have a 30x squared minus 11x is equal to 30. What do? We want to get the right side equal to 0, or any side equal to 0, so we could factor. So let's subtract negative 30 on both sides. Not negative 30 on both sides, just 30. So that's going to turn into 30x squared minus 11x minus 30 is equal to 0. All right. Whoa, right? It looks like a weird little factor that you guys have to do. But it's not too bad, actually, right? So we think of the factors of 30, both in the front and the back over here. And we think, what factors of 30 from this guy, what factors of 30 from this guy are going to either add or subtract to become that negative 11 right there, right? So we think about it, let's say factors of 30 are 1, 2, 3, 5, 6, 10, and 15 and 30, right? So we think, is anything really going to add or subtract up to 30 from any of these factors over here? I mean, to 11 from any of these factors over here? And I'm kind of not underlying the answer, which kind of defeats the purpose. But as you can see, nothing over here except that 5 and that 6 when combined together is gonna give you that negative 11. All right, so then let's try it out. We have, let's say, a 5x here. It's one of our factors, and the 6x here, right? And then that takes care of our 30x squared. Now for our 30, let's think. We could put a 5 here or a 6 here, right? So we want to make this a negative. So one of these is either going to be a positive and one of these is going to be a negative. All right, so let's think of which one's going to be positive. Let's just try it out, actually, because most of these factoring questions, when it comes down to big numbers like these, are going to come to trial and error, all right? But tips like these above, or like this above, sorry, are going to help you to get these questions out of the way. All right, so maybe let's try that minus here and that plus here. So let's FOIL it out and see if we get the right answer. So it's going to be a 5x times 6x. That's going to be a 30x squared. All right, so we have that first term. We have that 5x plus 6. That's going to give us a plus 30x. And then we have that minus 5 times 6x. So that's going to give us minus 30x. And then it's going to be plus 30. What could we have done wrong here? It might have been the placement of 5 and 6. So let's change it up. Let's make it so it's going to be 5x minus 6 times 6x plus 5. All right, and then we'll try it out again. We're going to get a 30x squared plus 25x minus 36x and a minus 30. We're getting somewhere. So that's 30x squared, a plus 25x, and a minus 30x is going to be a minus 11x. Oh man, and the minus 30, and that's our equation. So we figured out the answer. Well, not yet. It wants us to solve the following equation, right? So remember back here when we made this equal to 0? So now that we know that these two are the factors of this, we can make it so it's going to be a 5x minus 6 is equal, it's going to be 5x minus 6 times the 6x plus 5, and that's equal to 0, right? So now we could separate these two as being a 5x minus 6 equal to 0. Over here, let's kind of border these two. A 5x minus 6 is equal to 0, and a 6x plus 5 is equal to 0. So now we just have to solve for x on both of these. All right? So then we're going to have a 5x is equal to 6. Divide 5 on both sides. We're going to get an x is equal to 6 over 5 for that one. Do the same for this guy. It's going to be 6x is equal to negative 5 because we subtract negative 5. I mean a 5 on both sides. And then now we divide by 6 on both sides, and we're going to get a negative 5 over 6 as our second x. All right, and these two are our final answers. Right? So let's say you get this problem on a quiz or a test and you're boggled down by the fact that you really can't get anything to work out, right? So you're timed. So you're gonna want to make this question the absolute last question that you want to do if you don't get any factors, right? Because you want to get all the ones that you know out of the way and then really put your mind into this one, okay? But that little trick over here, that 1 times 2 times 3 times 5 times 6 as the factors of 30, and you're looking for ones that add or subtract to our middle one, which is negative 11 over here, all right? That's gonna help you out a lot. Or if you're really like stuck, just use our lovely formula, negative b plus or minus the square root of b squared minus 4ac over 2a. And this guy would have given you the same exact answer as we got here, all right? The only problem is that I think that you guys can't square root on your calculators, so finding out what the square root of the discriminant right here would have been a little bit challenging, but this would have given you the exact same answer as we got here. All right, guys, so method, what the heck is a square root method, right? I just take square roots. That's all I do. I never thought it would be called something, right? So, in fact, the square root method is just saying that, let me give you a simpler example instead of this one. Let's say we have x squared is equal to 1, right? Let's take the square root of both sides. So we get that x by itself. We're going to get that x is equal to plus or minus 1. And that's basically what the square root method entails. That when you take the square root of the, let's say, numerical side, we're going to be left with a plus or minus option of that numerical value. All right? So if we know that, let's take this example and apply it to this one. So we have 4y plus 2, this is all being squared, that's equal to 4. All right? Let's take the square root of both sides. Remember, the square root takes care of that too, because it's going to be a 4y plus 2 to the 2 over 2 power, which turns into just 1, which turns it into just itself. And that's equal to, the square root of 4 is 2, but the square root method entails you to have that plus or minus 2. And this method slash kind of fact is very, very important in any of your problems that might have a square root, right? Because you might just be like, oh, let me just take the square root of, let's say, 9. You're just going to have a 3. And then you're not going to get the right answer because it's going to be a plus or minus 3. All right? So now if we know that, that means we have to make this 4y plus 2 equal to a positive 2, and this 4y plus 2 equal to a negative 2. All right, so let's do that. We have a 4y plus 2. Oops, whoa. Hold the phone. All right. 4y plus 2 is equal to 2, and a 4y plus 2 is equal to negative 2. All right, so let's solve for y on both cases. So we're going to have a 4y is equal to, subtract 2 on both sides, we're going to get 0. Nice. So then divide 4 on both sides. 0 divided by anything is just 0. So that's going to be y is equal to 0 on that side. And then for this guy, we're going to subtract 2 on both sides. So we're going to get 4y is equal to negative 4, right? Because it's negative 2 minus a 2. And then we divide 4 on both sides, and then we're going to get y is equal to -4 divided by 4 is equal to -1. So our solution set, I know that you guys are given the choice to answer it in that terminology, like solution set or whatever, and they give you like these squiggly brackets or whatever, like this. Our solution set is just going to be 0 and -1. So whatever we get as our y or x values or anything like that, all right? Don't be scared about the terminology. These are just math guys trying to act smart. Over 7 plus x minus 1 over x plus 1. Jeez, okay. We look at this and we're tired. We're already tired. We don't want to do this one, but it's a test, so we have to. So what do? My first inclination is to separate the top and the bottom, all right? Just to make it easier for myself and get everything situated. Don't forget that it's still dividing though, right here, right? Don't want you guys to just care about the top and the bottom and not remember that there's a dividing sign, right? But if we know that, let's work on that 9 minus x plus 1 over x over here by itself. So we have a 9 minus x plus 1 over x, right? What do you guys know about this, right? This 9 over 1 is what? Oh man, I just gave you guys basically the answer for this one. This 9 is what? Remember in the other example where we had a 30x minus 11? We wanted to put it over 1, right? So we want to put this 9 over 1. So we have a 9 over 1 minus x plus 1 over x, right? What do we know about subtracting fractions? The only way in which you can do it is if they have the same denominator. But this guy does not have the same denominator as this. So what is it missing? It's missing an x. So we multiply an x on the top and the bottom of this guy to have the same denominator so we could use this operator. So we have, if we do that, it's going to be a 9x over x minus x plus 1 over x. And now we can combine this as being, I'm going to put it over here, as a 9x minus x plus 1 all over x, all right? That subtraction sign. Guys, remember, what is that subtraction sign telling you to do? Distribute that negative onto both this x and that 1. So it equals a 9x minus x minus 1 all over x. All right? So let's do one more step of simplifying like terms. We have a 9x minus x, which is an 8x. Subtract that negative 1. Yeah, I guess so. Yeah, it works. So it's going to be an 8x minus 1 over x as our numerator. All right, so we have that situated. Now let's move on to that 7x. That's 7 plus x minus 1 over x. X minus 1 over x plus 1. Right, so let's work on it over here. Just going to draw a little line there. 7 plus x minus 1 over x plus 1. All right, remember what we did? We wrote our numerical value over 1. All right, so what is this guy missing? That this guy has is an x plus 1. So what do? We multiply an x plus 1 over an x plus 1 times that 7 over 1 plus, remember we still have that plus x minus 1 and x plus 1 on this side, right? So then we're going to have a 7 times x plus 1 over x plus 1 plus x minus 1 over x plus 1. So now we have the same denominators, we can combine them. So we have a 7 times x plus 1 plus x minus 1 over x plus 1. Okay, so we have to distribute that 7 though, because it's connected by parentheses through multiplication. So that's going to turn into 7x plus 7 plus x minus 1 over x plus 1. All right, one last step, combining like terms. So it's 7x plus x, and that's equal to an 8x. 7 minus 1, that's just going to be a plus 6, all over x plus 1. All right, so that's our numerator right now. So let's combine everything, and we'll have an 8x minus 1 over x over 8x plus 6 over x plus 1. Okay, wow, we still have these fractions, but what we can do is keep, change, flip, right? What does that entail, guys? That entails just flipping this guy to turn into, let's have an 8x minus 1 over x to turn into multiplication of x plus 1 over 8x plus 6. So what do? We flip this guy and we and now we're going to multiply times it, times the denominator, okay? Once we flipped it. So now we have an 8x minus 1 times x plus 1 all over x times 8x plus 6. All right, nothing really to factor out except for in the denominator where we have an 8x plus 6, right? What's the same between the 8 and the 6? A 2, so we could take out a 2 from here. So if we do that, it's going to be 8x minus 1 times x plus 1 times 2x times, if we take out a 2 from 8, it's going to be a 4x. Take out a 2 from 3, it's going to be plus 3. And that is our final answer. Okay, any questions on that mess of a problem? Get through it. So here we are, getting through it. All right. So what do we want to do? Like we did in the prior problem, kind of want to separate this guy and this guy. That was almost a perfect square over here. It's a horrible circle. But if we do that, we have an x plus 8 over x squared minus 3x minus 28 minus, don't do the minus yet, but 3x plus 1 over x squared plus x minus 56, right? So for this problem, we want to find out if we could subtract, right? To find that out, we have to see if these have the same denominators. So to find that out, we have to factor the denominators out, right? So factors of 28, that's going to give you a 3. If we think about it for a little bit, that's going to give you a 7 and a 4, right? To give you that minus 3, you want that 7 to be negative, all right? And that 4 to be positive. So if we do that, it's going to be an x plus 8 over x minus 7 times an x plus 4. Subtracting 3x plus 1. And now for this guy, a 56, factors of 56 that are going to add or subtract to 1. Because remember, this is basically a 1 in front of the x. If we think about it for a little bit again, it's going to be 8 and 7. All right. We want that 8 to be positive and that 7 to be negative, because 8 minus 7 is going to give you that 1 right there. So if we know that, it's going to be an x plus 8 times x minus 7. All right. So now we look at the denominators of both these and think, what is the same and what's different between the two? All right, we have an x minus 7 here, an x minus 7 there, an x plus 4 here, but not an x plus 4 here, and an x plus 8 here, but not an x plus 8 here. All right? So if we want to get them the same, we want to have the same denominator, we have to first multiply this guy by an x plus 8, since this is what these factors are missing. So we have an x plus 8 times over x plus 8 times x plus 8 over x minus 7 times x plus 4. All right. So on this side, what do we want? We have an x plus 8 and an x minus 7. The only thing that we're missing is an x plus 4. So we multiply 3x minus 1 over x plus 8 times x minus 7 times an x plus 4 over x plus 4. Right? Moving on over here, we multiply the numerators. So an x plus 8 times x plus 8, that's x squared plus 8x plus 8x plus 64 all over now an x plus 8 times an x minus 7 times an x plus 4. Right? And that's the left side over here. Subtracted by a 3x minus 1 times x plus 4. So that's 3x squared plus 12x minus x minus 4 all over the same denominator, x plus 8, x minus 7 times x plus 4. Right, now we have to combine like terms, so that's going to be x squared plus 16x plus 64. So now let's just look at the numerators now, since they both have the same denominators. So that's a minus. Remember, that minus is going to come through and distribute inside. So we want to put that parentheses. So it's going to be 3x squared, 12x minus x, that's a plus 11x, minus 4. All right, just worrying about the numerator now. So now let's distribute that negative inside. So that's x squared plus 16x plus 64 minus 3x squared minus 11x minus, and then minus 4 is going to give you a plus 4. Right? So now we combine all these like terms, we're going to get a minus 2x squared. 16x minus 11x is at plus 5x, and the 64 plus 4 is at plus 68, all over our lovely denominator, which we figured out as being x plus 8 times x minus 7 over x plus 4. And that is our lovely, beautiful, final answer. All right? So for these problems, we want the same factors for the denominator, so we could actually do the operator, which is either going to be subtract, add, divide, multiply, stuff like that. Okay, guys? What does that even mean? So we have a denominator, right? With the square root. And we think to ourselves, do we really want that square root to be there? And the answer is definitely not, all right? And the answer to that problem is rationalizing the denominator. And doing that is just multiplying times the conjugate of our denominator. And the conjugate just means that it's going to be the opposite of what we have. So let's say instead of a plus 2 times the square root of 7, let's say we had a minus 2 square root of 7. Our conjugate, let's say our C, is going to be 9 plus 2 square root of 7. All right, you guys got it? So if it's a plus here, it's going to be a minus here. If it's a minus here, it's going to be a plus here. Right? So if we know that, we're going to multiply the top and the bottom. All right, don't forget this. You have to multiply the conjugate times the top and the bottom. All right, so we have a 7 minus square root of 7 over 9 plus 2 times the square root of 7 times a conjugate, which is 9 minus 2 square root of 7 over 9 minus 2 square root of 7. Right? It's focusing on the numerator here. We have a 7 times 9. We're just FOILing it out. So it's a 7 times 9, which is 63. A 7 times minus 2 square root of 7. So we're going to just focus on the coefficients. So that's going to be a minus 14 square root of 7. And then we have a minus square root of 7 times 9. Focusing on the coefficients once again. We have a minus 9 times the square root of 7. Alright? And we have a minus square root of 7 times a minus 2 square root of 7. Alright, so little lesson here. We have minus square root of 7 times a minus 2. What did I just do? Okay, going back. Minus 2 square root of 7. Right? They're multiplying. But remember in the first few questions where we rewrote the square root, we could do the same here as being minus 7 to the 1/2 times a minus 2. Hopefully that dot registers, times 7 to the 1/2. Alright, we have the same bases here, so that means we can combine them. So we have a 7 to the 1/2 and a 7 to the 1/2. When we multiply exponents, we basically just add the exponents. So we have a 1/2 plus a 1/2. So that in turn is going to give you a minus 7 to the 1 times a minus 2. So that's going to be minus 7 times a minus 2. It's going to give you a lovely 14. So we have a plus 14 here. Alright. And that's our numerator. So the denominators for these guys share a lovely property. When we multiply conjugates of each other, we're going to have a thing called a difference of squares. So let's say our 9 is our A is equal to 9, and our B is equal to 2 times square root of 7. Alright, so our difference of squares just means that this A squared minus B squared, A minus B times A plus B, that's going to equal to just A squared minus B squared, right? So when we're multiplying, we see that it's in this form right here. So then we could follow the difference of two squares property. So we have A as 9, so we do 9 squared, so that's 81. And we have B as 2 square root of 7, so 2 square root of 7 squared, right? That 2 is going to be squared, so that's 4, and that square root of 7 is going to be squared, so it takes care of that square root sign. it's gone, and it's going to be 4 times 7, which is equal to 28, right? So now we know what our b squared is, so now we just subtract minus 28, all right? And now we have our numerator and denominator. All we have to do is combine like terms. So we have a 63 plus 14, which is 77. And we have a negative 14 square root of 7 minus 9 square root of 7, which is a negative 23 square root of 7. And an 81 minus 28, which is a lovely 53. All right. And that is our final answer. And that is our last question of the day.